I think we're ready to get the meeting started with our first speaker, Arnold Brody, and the sky this month.
Well, thank you, Paul. Thank you, Paul, and hello, everyone. Tonight, I will cover the period from tonight to March 2, the night before our next online meeting. Dates, times, and simulations you'll see are based on the Eastern time zone. I also did the sky this month for February last year at the Ontario Science Centre. Then the pandemic hit and we've not been back. Fortunately, our meetings have continued uninterrupted, as Paul was just mentioning, thanks to the AV committee and volunteers streaming our meetings online. And I'll repeat their names as a shout out to Andrew and Betty Reed, Ward LeGros, Ennio Salusi, and Blake Nancaro. Thank you for keeping us connected. Now, tonight, we'll take a look at some astronomical anniversaries, a quick review of space missions, and then jump into February observing. Now, there are hundreds of astronomers whose birthdays are in February, according to the Born Glorious website. For brevity, I've picked two giants who opened the door for modern astronomy. First, Copernicus, born this month in 1473. He disliked the Earth-centered universe of Aristotle Ptolemy with planets riding on epicycles. So he put the planets, including Earth, in orbit around the sun, and the epicycles were gone. Simple. He published his theory in De Revolutionibus Orbium Coelestium on the revolutions of the heavenly spheres. And knowing the danger his book would put him in, he waited until his last days to publish. Copernicus was followed a century later by Galileo, born in February 1564. Now, Galileo turned his handmade 37mm telescope to the sun, moon, planets, and stars in the sky in the early 1600s, and in 1610, he reported his findings in Sidereus Nuncius, the starry messenger, which challenged conventional wisdom and drew the ire of the church. He was familiar with Copernicus's sun-centered model and promoted it in dialogues concerning the two chief world systems, which led to his conviction for heresy and house arrest. Galileo is known as the father of modern science through the use of experimental evidence to test theories. Of the many astronomical events with anniversaries this month, here are three. In February 1845, the Leviathan of Parsonstown saw first light and became the world's largest telescope for 72 years. In February 1930, Clyde Tombaugh found Pluto with a comparator machine that showed a dot moving between photographic plates that he exposed through a 330mm telescope at the Lowell Observatory. And in February 1974, Mariner 10 became the first spacecraft to use a planet, in this case Venus, for a gravity assist on its way to Mercury. Now, for some mission updates, on January 14, Blue Origins successfully tested their suborbital space tourism system with the new Shepard booster, reaching the planned apogee and successfully recovering both booster and capsule. Revenue from tourists taking the 11-minute trip above the Kármán line, starting later this year, we believe, will help fund missions under development, such as the Blue Moon crew and cargo trips to the moon. On January 17, Richard Branson's Virgin Orbit had a successful second demonstration of their liquid-fueled Launcher 1 rocket that was air-launched from under the wing of Cosmic Girl, a modified Boeing 747-400. They deployed 10 CubeSats for NASA in the demo. Launcher 1 demos are now complete, and VO bookings have bookings with the US Space Force, UK's Royal Air Force, Swarm Technologies, and others. Elon Musk's Starship SpaceX, I should say, they ran a second Starship belly flop landing attempt yesterday. And like serial number 8, serial number 9 failed to stick the landing due to a Raptor engine not reigniting. Meanwhile, SN10 stands on an adjacent launch platform waiting its turn to try later this week or next. Hopefully, it was paying attention. Every 26 months, as Earth approaches Mars, a 2 to 3 week launch window opens for efficient trips to the planet. This animation shows the InSight mission using the 2018 window. This past year, a Mars window opened in July, and missions from 3 national space agencies jumped through it. The Emirates Mars mission, HOPE, will enter into Mars orbit on February 9 and become Mars's first weather satellite as it studies the atmosphere and watches windstorms. The China National Space Administration sent Tianwen-1 on its way to Mars on July 23. It is an orbiter with a lander and rover. Orbital insertion will occur on February 10, with the lander and rover landing sometime in May. NASA's Mars 2020 mission launched on July 30. It consists of the Perseverance rover and the Ingenuity helicopter. And on February 18, Perseverance will use the Sky Crane to land into Jezero crater. Okay, now on to observing. For the astrophotographers, the sky is as dark as possible, with the sun at least 18 degrees below the horizon for about 10¾ hours tonight, down by 49 minutes a month from now. Visual astronomers can enjoy observing an extra hour by including astronomical twilight. An outburst of activity on the sun's southern hemisphere back in November signaled the onset of solar cycle 25, but activity has taken a pause since. Here's an image of the sun taken 4 days ago showing a spotless complexion with 0 sunspots, 0 new regions. The view from stereo A does not promise any activity that will rotate into view. Stereo A satellite trails Earth on our solar orbit by 60 degrees, so our views do overlap. Stereo B is 60 degrees ahead of Earth, but it failed 5 years ago. A team led by Scott McIntosh has made a bold prediction for solar cycle 25, shown here in red. They say cycle 25 will be augmented by a secondary cycle and could reach maximum in just 2 years in 2023, with an awesome sunspot count as high as 250, more than double the 120 max that cycle 24 achieved. And it would be more than any sunspot count ever previously recorded. That's enormous and a stark contrast to the steady decline we saw in sunspot numbers over the last 4 cycles. NOAA, NASA, and the International Solar Energy Society say 25 will be just like 24. That's their estimate in blue, and green is the historical average. Now, how cycle 25 plays out will help space weather forecasters perfect their models that are needed for planning crewed missions to the Moon and Mars. As for the sun in our sky, it climbs 9½ degrees from 30 degrees up tomorrow local noon to 39½ by March 3, squeezing the night window as a result. If you're searching for any cycle 25 activity, you're looking through 2 atmospheres at local noon at the start of February. On its way to a minimum of only 1.1 atmospheres that you'd be looking through when you examine the sun on the summer solstice when it gets as high as possible. So your resolution examining the sun through your Coronado or other solar filtered scopes will improve over the next 4 months as the sun climbs higher. Now on to the moon. This animation from NASA's Visualization Studio shows the moon's phases, vibration, and distance from Earth this month. You'll notice it reaching apogee around first quarter on February 19, and then dropping towards perigee in early March as the moon ages towards last quarter again. The window for deep sky observing without moon interference is opening now and runs for the next 10 to 12 days. The last quarter moon is tomorrow with new moon a week later. And perigee and apogee occur a day before last and first quarter moons respectively. February's full moon, commonly known as the snow moon or hunger moon, rises on the evening of Saturday, the 27th. Now, asterisks you see in this calendar identify dates with interesting moon events. Let's check them out, starting with Monday, the 15th. On that day, lunar libration tips the northeast limb of the moon in our direction, giving us a chance to take a peek at the floor of crater Heian and study Mare Humboldtianum, one of two lunar mare named after people. Situated next to the unseen side of the moon, Humboldtianum was named after Alexander von Humboldt, a prominent 18th and 19th century explorer of unknown lands. By the way, the other mare named after someone is Mare Smithii, named after British admiral and astronomer William Henry Smith, a contemporary of von Humboldt's. That same night, a few minutes before 9 p.m., you can watch the dark limb of the young moon occult 29 Ceti, a magnitude 6.4 star, so you will need binoculars or a telescope to see it. Have you heard of the lunar S? It was found by Blob Rana several years ago, and it's possible to catch it on the moon's southeast quadrant near crater Theophilus on February 17th. On the 19th, there will be a lovely sight high in the southwest as the first quarter moon glides between the Hyades on the left and the bright Pleiades on the right, with the red glow of nearby Mars right behind. The Hyades is very close, only 153 light years away, and dense with hundreds of stars, the brightest forming the V shape of the Taurus bull's face. By the way, the bright red Aldebaran, the eye of the bull, is not a member of the Hyades. That's it right here. It's less than half as far away at only 65 light years. And do you see this orange star just east of the moon? That's 43 Tauri, magnitude 5.5, a K2 red giant, and it's about to be occulted by the dark limb of the moon. Here's a telescopic view, a mirrored simulated view through a small refractor. That's why it's flipped around. And when we look through a telescope, we can see a second star about to be occulted. It's a 7.7 magnitude type double. Maybe it will wink out in steps. After watching the occultation, you can turn your telescope onto the moon and study a number of features along the terminator. The uneven surface of Mare Imbrium is highlighted by the shallow angle of sunlight illuminating the eastern side of the Sea of Rains. Mare Imbrium was formed 3.8 billion years ago, towards the end of the late bombardment period, from a strike by a protoplanet asteroid estimated to be around 250 kilometers in diameter. The impact created a basin that was 100 kilometers deep before the surface rebounded and filled with lava, which you can now study in the shallow sunlight. It's a good opportunity to study the tall, rugged mountains, Montes Apenninus, that borders the southeast shore of Mare Imbrium. The range is over 5 kilometers high in places and is well defined by its shadows. The moon will be below the horizon for us when the lunar X and V are perfectly illuminated along the terminator, but we can still study them and the craters whose rims formed them in sunlight on the 19th. And we can watch sunlight begin to reach the floors and central peaks in the large craters in the southern highlands, such as Mauritius. Now, the moon is at its highest in winter, so you should be looking through only 1.1 air masses when studying these features. A very good opportunity. And speaking of opportunities, there's another one to see the advancing dark limb of the moon cover a magnitude 6 star on Sunday, February 21, around 10:18 p.m. On February 24, the nearly full moon passes close to M44, the Beehive cluster in Cancer. The inner circle is 4 degrees wide, the view you would get with an 80mm refractor and a low-power eyepiece. Of course, the view inside that circle should be flipped left to right to match. The other circle is a 7-degree field of 10 by 50 wide field binoculars. And I think those would be the preferred equipment for looking at that lovely sight. And here we see the moon less than 10 arc minutes from 4.6 magnitude Gamma Cancri at 8:49. Back in October, I talked about a great parade of planets across the sky. Well, the parade has marched down the street and around the corner and is out of sight. and all we have left now are Mars and Uranus lingering in the west. Tonight, Mercury sits less than 10 degrees from the sun and getting closer for the next few days, making it unsafe or impossible to see it. On March 2, Mercury is visible in the east before sunrise, but very low due to the shallow angle the ecliptic takes at sunrise this time of year. There will be more favorable times to catch Mercury, such as May 15, when Mercury will be 19 degrees high in the west at sunset, at a convenient evening hour, not pre-dawn. It will be much warmer then, and the bugs won't be out yet, so that might be your best chance to see Mercury. Venus is very low in the east before sunrise at the start of February, and even lower as we enter March. With the sun rising shortly behind Venus, this is really not a safe time for you to observe it. Venus becomes the evening star later this spring as it rises higher in the west after sunset. Venus will climb ever higher in the southwest throughout the summer and fall. Here we see Venus 8 degrees above the southwest horizon after sunset on October the 30th. That's the date when Venus is as far as it can get from the sun. So viewing is, of course, very safe. It will take a while to set. So if you would like to have a good look at Venus, your best opportunities will be this fall. Mars is a fading red dot in the west, climbing higher throughout the month. We're orbiting directly away from Mars, so it shrinks and fades significantly. And you might not see any features on the tiny disk, but you might want to give it a look anyways, knowing the amount of attention that Mars is getting with those 3 missions arriving there later this month. We don't fare much better with the outer gas and ice giants. Our sight lines towards Jupiter and Saturn, towards Pluto or towards Neptune, those sight lines pass right by the sun, making those objects pretty hard or impossible to see. Now, Jupiter and Saturn, they have recently passed superior conjunction behind the sun, and they will gradually return to the pre-dawn sky as Earth races around the sun to move it out of the way. But we're going to need to wait until spring to really start observing those gas giants in any detail. Uranus lingers in the west like Mars, with Earth pulling away. Uranus is a very small blue-green disk at 3.5 arc seconds, found 8.5 degrees east of Gamma Auritus. And that's it for planets. Not much now, I'm afraid. There are 2 comets crossing the southern sky this month. Comet Neowise will pass through Monoceros, under the feet of the Gemini twins, and past a few open clusters in Auriga, coming within 35 arc minutes of NGC 1907. Meanwhile, Machholz travels eastward from Cetus to Orion, and below each are magnitude estimates over the last week or two by observers using 8 to 12-inch telescopes. And those estimates of 11 magnitude or brighter suggests that we should still be able to catch those comets through similar equipment this coming month. 2 asteroids passed through opposition this month, 113 Amalthea and 29 Amphitrite. Asteroids, of course, will travel at the quickest in our sky when they're at opposition. And if you would like to visualize an asteroid's orbital motion in real time or record it, you can watch Amphitrite cruise within 10 arc seconds of a pair of closely spaced stars on Monday the 15th. Closest approach is around 1:30 Tuesday morning. And here we have a simulated mirror image view through an equatorial 10-inch SCT and a 9mm eyepiece. We're at the end of twilight around 7:30 when these objects first become visible. And in 4 hours, Amphitrite makes its closest approach. On the new moon night of February the 10th, a 40-kilometer wide asteroid, 515 Athalia, occults a magnitude 12.5 star in the constellation Gemini around 2353 in southwestern Ontario. The occultation is expected to last up to 6 minutes on the center line, although there is a lot to be learned about the shape of an asteroid by taking timings across the width of the eclipse path between these 2 blue lines. Here's an example of the profiles of the twin bodies of asteroid 90 Antiope, based on timing submitted by 37 observers spread across that particular eclipse path. If you are interested in learning more about timing occultations and making submissions, you can visit IOTA, the International Occultation Timing Association, at the two websites shown here. A week later, on the 18th, there is another occultation that passes across southern Ontario, including Mississauga, Etobicoke, and downtown Toronto, south of the Eglinton St. Clair. The magnitude drop is not as great, but enough to detect with astro camera tracking the star. So if this sounds like something you'd be interested in trying and have the needed gear, you have two asteroid occultations only 8 days apart to try your skills on. So good luck with that. I'm sorry, there are no meteor showers this month. They will resume in the spring. So when it comes to observing the solar system this month, we can monitor the start of solar cycle 25. We can study the moon, watch a couple of comets, and maybe watch occultations involving the moon and asteroids, and that's pretty much it. We'll need to wait a month or two for most of the planets to return to the pre-dawn sky. Until then, let's check out the stars in deep sky. If you're out for that occultation of 43 Tauri by the first quarter moon on Monday the 19th, chances are you'll also explore the sites in Orion. Now, while you're there, there are 4 double stars from the Double Star Observing Certificate in the constellation. And here's how they look in simulated 6 arc-minute circles, inverted as though you're looking through a Newtonian or reflector scope. Now, 41 Orionis, otherwise known as the trapezium, I don't think it will be sitting in a dark field as suggested here. That's because it's in the middle of the Orion Nebula, so there's lots of glowing gas and dust, I would expect in your view. On the 9th, demon star Algol drops in magnitude by 75% when bigger and dimmer Algol B passes in front of brighter Algol A. The two stars are so close together it takes just over 2.5 days for the pair to complete one orbit around their barycenter. When the dimmer B slips behind A, the drop in magnitude can only be measured with equipment. Algol is bright at magnitude 2.1 at max, and its entire eclipse can be monitored with your eyes alone. You can watch an Algol eclipse already underway at nightfall on the 9th. Algol will already be dimmer than Almac or Gamma Andromedae, but how dim? Will it be like 2.9 epsilon Persei? Will it be like 3.0 delta? And which, by the way, these two stars is a good test of discerning a 0.1 difference in magnitude. By 8:35, Algol will be at minimum as dim as magnitude 3.4 Alpha Trianguli and stay there for 2 hours. 9:35 is the midpoint of the 2-hour minimum. Alpha Trianguli will probably look dimmer due to atmospheric extinction because it's 20 degrees further down, closer to the horizon. So you're looking through more atmospheres. It may not appear as bright as Algol. It may be even dimmer. But if you're observing past 10:35, Algol will begin to rebrighten. Take a look every 15 minutes and compare it to its neighbors as it rebrightens. Another variable you can watch dim and rebrighten with your eyes alone is delta Cepheii, after which the delta Cepheid class of variables is named. The star is pulsating as it has not reached equilibrium between the atmosphere wanting to collapse and the release of fusion energy in the core pushing back. This results in the star heating up and cooling off, causing a fluctuation in brightness between 3.48 and 4.37, with a 5.4-day period. At its brightest, it's nearly the same as Zeta Cepheii, and slightly dimmer than Epsilon when at minimum. You can compare Delta with its neighbors on any clear night since the constellation Cepheus is circumpolar. Although when it's higher up in the sky, you get a better, clear look at the magnitudes. Now, the period of fluctuations tells us the absolute brightness of a Cepheid-type star, and the star's apparent brightness depends on its distance. So by comparing a Cepheid's actual versus apparent brightness, we can tell how far away it is, or how far away a galaxy is with a Cepheid in its arms. That's how Edwin Hubble determined the Andromeda Nebula was actually a galaxy far outside our own, by discovering a Cepheid in Andromeda in his photographic plates that he took in 1924. Now, if you would like to learn more about observing variable stars and submitting magnitude estimates, visit AAVSO at the website shown here. They will give you some training on how to observe variable stars, and then you can be able to make submissions to them. With Valentine's Day on February 14, I would like to suggest a few deep space targets along that theme. Some of you may remember these targets from when I did the sky this month last year. First on our list is the Heart Nebula. We get a bonus with the Heart soulmate, the Soul Nebula, only 2 degrees away. This gorgeous image of the Heart and Soul Nebula was produced by Adrian Aberdeen from his apartment balcony in Toronto, and is found on our forum's astrophotography section, where you can find Adrian's write-up and imaging details. Now, whereas Adrian pushes the blue component a lot in his post-processing, it's his favorite color, the 2 nebulae grow predominantly in the red of ionized hydrogen. They can be viewed visually with moderate to large amateur telescopes under dark conditions. You can find the Heart and Soul Nebula 6 degrees north-northwest at the Persei, the star at the tip of the hero's cap. Do you see a heart-shaped pattern in the brighter stars of this open cluster? Maybe like this. The heart-shaped cluster is M50, discovered by Charles Messier in 1772 while observing a comet. It is a rich cluster with 500 stars, and it is still quite young at 140 million years old. It can be found almost halfway on a line between Alpha and Beta Montes, slightly closer to Beta. It's easy to find at magnitude 5.9. Next on our tour is the Rosette Nebula, also known as Caldwell 49, seen in this image by Jeff Booth. It's a large spherical H2 region, circular in appearance, located in the Monticeros region of the Milky Way galaxy. NGC 2244, or Caldwell 50, is the open cluster of stars found in the nebula's center, having formed from the nebula's matter, and are now exciting the leftover gas to glow red. The nebula and cluster lies some 5,000 years away and has an estimated mass of over 10,000 solar masses. Oh, and to encourage others, Jeff would like you to know that he imaged this nebula from his backyard in, quote, light-polluted Oakville. There is an easy 2-step star hop that will take you to the Rosette Nebula. First, find magnitude 4.5 star, 13 Monticeros, 9.5 degrees east of Betelgeuse, almost 1 fist to the left. Next, with your telescope aimed at the star, slew south 2 degrees and the open cluster NGC 2244 will enter your eyepiece. The Rosette has an apparent magnitude of 9, and the embedded open cluster will be easier to see at magnitude 4.8. To see the nebula surrounding this brilliant cluster, you will need dark skies and a narrow band nebula filter to dim down the cluster. This cluster is truly amazing. It is very young, at less than 5 million years old. Its brightest 2 members are fearsome O-class monsters, the most luminous stars in the main sequence. One is 450,000 times brighter and 60 times more massive than our sun, and the other is 400,000 times brighter and 50 times more massive. By comparison, Sirius is twice our sun's mass, Betelgeuse 11, Antares 12. Now, stars this massive exhaust their fuel in only 3 million years, putting an upper limit on how old this cluster can be. By the way, 12 Montesirotis is not a cluster member. It's around 500 light years away, not 5,000 like the cluster. Our final Valentine's treat is this merging pair of galaxies, NGC 4038 and 4039, located 45 million light years away in Corvus. Tidal interactions have resulted in two long streamers of stars, dust, and gas being ejected in curving arcs, resembling an insect's antennae. The original spiral structures of the two galaxies have fallen together to become the two lobes of a heart. The collision has triggered starburst, raising the nebulosity of each to magnitude 11, within the reach of visual observing from dark skies with 8-inch or larger telescopes. We can use the stars across the top of Corvus to locate the merging galaxies. Go from Algol to Gienah and continue that same distance, and you'll be less than a half degree north of the merging galaxies. Being in Corvus, the galaxies do not rise very high in the south. On the new moon night of February the 11th, they rise at 10 p.m. and reach the meridian around 3 a.m. at a height of 27 degrees, and that's about as high as they get in southern Ontario. So these are the various online resources, the planetarium software used to generate the images, and I thank these people under Astro Images for their wonderful deep sky photography. Thank you. Any questions?
Thank you very much, Arnold, for a thorough presentation. I know it takes an awful long time to make the presentation, so thanks again for all the time you invested. Let's go to Ward. Any questions from our online audience?
Just one question from Blake right now. He was wondering what the source was who said that the next solar cycle was going to be so great.
Well, let me jump back to that slide and show it to you again, if I can. Well, let's see. And that was about the solar cycle 25.
That's right.
Yeah, this slide here. Macintosh and company, they are either funded by or work for the National Center for Atmospheric Research. So they're independent of the federal agencies such as NOAA and NASA. Macintosh, Scott, he says that there's a 22-year cycle. Maybe it grows and weakens, but he says it's going to merge with the normal 11-year cycle, and that would account for this terrific jump. If he's right, it's a major change in our ability to forecast solar activity, and that, of course, is important when we're contemplating space missions with astronauts in space for years, traveling to, let's say, distant planets, or orbiting Mars for a number of years. How much radiation is the sun producing? How can we predict it? This is a very interesting subject that's being advanced, especially with additional information coming from the Solar Dynamic Observatory. There's more data that's being used to try and figure these things out.
Excellent. Thanks very much.
You're welcome.
No other questions.
Okay, thank you, Ward. Thanks again, Arnold.